Today we're going to be working on 8.1 and your homework's going to be from page 320. There's a PDF file on our page dated April 14th where you can upload that document, or you can go to your book if it's easier to see. Don't forget the answers are on the left-hand column of the main page on the LMS, and you just have to scroll and find the correct answers. So today, looking at this, we're going to walk through different features, specifically how A impacts quadratic functions. So quadratic functions look like this in terms of an equations: y equal ax squared plus bx plus c. And the shape of these functions looks something like this. They're U-shaped, okay? And they're either up or down. So again, we're specifically today just going to focus on A and how that impacts the shape of the quadratic function. And later on, we'll look at other parts of the function, see how they impact the parabola. So if we scroll down and we look at some graphs, and we're not going to write bx plus c, but we know it's quadratic because quadratic, the power is 2. So there's going to be a coefficient in front of x squared, and if you don't see a number like 2 or negative 0.4, you always know it's a 1. But because the power is 2, we know it's a quadratic, and we know it has the U shape. Now, when we're looking at these functions, the parent, the most basic, would be y equals x squared. And we know that when we don't see a value in front, we know it's a 1. So you're always comparing to the number 1 when we're going to make comparisons. But for parent, again, the a value is a 1. Okay, so that's going to be our a value for the parent function. So up here, we know that this is the parent. Now, when we look at this function, we're just going to notice a few different things. We notice that the parent function changes directions. So if we look from left to right, it's heading downwards, and then we hit this point, which is called the vertex, and that's where this function changes directions, and then it heads upwards. Okay, so the vertex for the parent, and we'll talk about how to find that later, is 0, 0, because that's where it changes direction. And then the axis of symmetry is that vertical line that slices through our graph, and it makes both sides symmetric. So if I were to take the right side, this red on the right hand side, and we'll use a different color. If we were to take this, the red on the other side, and we were to flip along the axis of symmetry, you would see what we call a reflection. And the purple would be the reflected value. That's why this pink is called the axis of symmetry. So the pink splits through our graph. And since it's a vertical line, remember vertical lines, V, U, X. So vertical, V in Vux, right? Hoi Vux. V stands for vertical, and we know vertical looks like that. And we know they are X equal values, right? And we say X equals 0 because if you see that the vertex where our parabola changes direction is at 0, 0, the X coordinate is 0. So we say X equals 0. And we're going to do a dotted line when we're talking about this axis of symmetry, that vertical line x equals 0, because when we go to graph this, you don't actually see that image, but we are just stating that that's where we're going to see the reflection on either side of that vertical line. So dotted means we're not actually going to have those points on the dotted line, but that's where it slices through the graph, slices through the vertex. Now, let's look at this image beside it. If we have a vertical line that slices through, because we know the axis of symmetry for both of these is x equal 0, and we'll get to how to find our vertex later, but for both of these graphs, when you don't see a bx plus c, you just see y equals a number x squared. Your vertex is always going to be 0, 0. And again, we'll get to how to find the vertex later. And we know our axis of symmetry is always the x coordinate of the vertex. And I'm going to write AOS for axis of symmetry. And again, it's the x coordinate of the vertex. So then when we look at these graphs, we're trying to make a comparison as to how that a value impacts the graph. So if we look at the first one, we look at the top red equation, we see that our a value is 0.5 versus the bottom one has an a value of -2. A is the number in front, right? And for the top one, for the red, we notice two things. We notice that for the red graph, it is pointing upward. And if we look at the a value, how does the upward versus downwards compare based on the a value? Well, for the top one, that red function that we see, the a value is positive. And if we look at the bottom one, the a value is negative. Therefore, we can come to the conclusion that if the a value is positive, our graph is going to open upwards. And if our a value is negative, our graph is going to open downwards. And then let's also look at this. So for the top one, our a value is 0.5 or a half, and the bottom one is -2, right? So and we see that the top one is wider than the bottom one, right? It's wider and the bottom one is narrower. So we say if the absolute value of a is greater than 1 versus the absolute value is smaller than 1. So if the a value is greater than 1, let's look at this bottom one. If the absolute value of a is -2, so 2. If 2 is greater than 1, so if the a value is bigger than 1 absolute value, our graph is going to be narrower. And use an n for narrower. Narrower. And if we look at the absolute value of the a value and it's less than 1, like the top one, 0.5, if it's smaller than 1, it's going to be, I'm going to use W for wider. Okay, so those are some things we notice about A. A does two things. It tells us if it's upward or downward. So since the top one has an a value that's positive in green, it opens upward. For the bottom one in blue, since the a value is negative, -2x squared, it's going to point downward. And it also does another thing, absolute value. If the absolute value of the top one, absolute value of 0.5 is 0.5, since that's smaller than 1, the graph's wider than the parent function. Well, I'm sorry, I should say, since it was, let's say, since it's absolute value of 0.5, it's less than 1, so it's wider than the parent because we're always comparing to 1. And for the bottom one, since the absolute value of -2 is 2, that's greater than 1, so it's going to be narrower. So it's kind of opposite of your intuition. Now let's look at the absolute value graph, right, versus our quadratic or parabolic graph. So we say absolute value, we see those absolute value bars, right? And the bottom we say quadratic because the highest degree is x squared. We don't see a bx and a c, right? So for the top one, we notice, if we remember from before, that our vertex is at 0, 0, right? And for the bottom one, our vertex is at 0, 0. So that's the same for both of them, right? Our vertex is at 0, 0. Our vertex is also at 0, 0. And we see that for both of them, they also have a line that slices through the center, slices through the x coordinate of the vertex, and since it's a vertical dotted line, we would say the axis of symmetry. Since it's vertical, hoi vux, it's x equal 0 for both graphs, for the parent functions of absolute value and quadratic. Okay, and then if we also look at both of them, since we don't see a number in front of the absolute value bar or a number in front of x squared, we know it's a 1. And since 1 is positive, if it has a positive a value, they both open upward, right? Now, if we were comparing narrow versus wider, these are both parent functions. Absolute value of the a, absolute value 1 needs to be bigger or smaller for the graph to be wider or narrower than the parent. It's neither, so we would just say it's neither wider or narrower than the parent, okay? So, how are they similar? And how are they different? Again, we said over here, we can just look over here. They're similar, they have the same vertex. They both open upward. So we can write that. Same vertex. That's 0, 0. And we have the same axis of symmetry. And they're both x equal 0. And then what do you notice about the axis of symmetry in the graph? They're also the same, so I guess I wrote it up there. Okay. So this would go down below in this spot. Morning. Okay, you're going to watch the second video for the remainder of these problems.